Hello, my name is Ilirian Ibrahimi, and in this video I'm going to demonstrate you the performance of our proposed NLP approach on how it reuses the knowledge of existing models that are persisted on a knowledge graph and that can be directly queried or used from natural language provided on the zAppDev low-code platform. zAppDev is a low-code platform supported from CLMS, and here we are currently within the development part on the modeling canvas exactly on zAppDev. If you want to use the services provided, so for the services for getting model reuse through natural language processing or using n-grams, which I have explained on a previous video, you have actually to go within the developer part on zAppDev, and it is not within the free trial here. So we have to click on this button to trigger the respective user interface where we can prompt our request what we want to get from our service. And let's say if we say a request, so we can ask to get a completed model. We can ask if we want to have a model containing specific classes or classes containing specific attributes or that are related to specific other classes, etc. So if I say I want on say invoice model, so the approach directly queries our knowledge graph based on the relevant tokens extracted from this prompt here. And yeah, we will have a lot of classes here which are all belonging to the so invoice model. So you can select one or multiple or all classes here, and if you click OK, they will be directly integrated within the modeling canvas here. Or let's say you can ask, for instance, having or a specific class. Let's say I want, I mean, you can construct your request in different ways. It's not that important. Say, give me a or invoice class. No, invoice class. And if we click search, we should get only classes related to invoice. And here we have, for instance, invoice product or the class itself invoice. I mean, you can have a lot of different types of queries. So case of queries, for instance, give me a class related to, let's say, to trip, as we have done in our paper, the examples here. So we will have, for instance, here trip, urban trip, or yeah, trip details response, so which are all classes related to trip here. So let's say give me a class that has attribute, what can I say, start date or so, start date. Then it just checks, okay, all the classes within the knowledge graph which has an attribute start date and and returns all there uh, to this recommendation list, which can be selected and directly integrated within the modeling canvas here. You can say different type of queries, which are all here provided in our paper. Yes, so and the way, as we have explained here, how it works is a case-based NLP. So, for instance, if you have a combination of tokens, so like connect, that or relate, then it guesses that you are looking for a class which is related to another class, and where all the stop words and irrelevant tokens will be directly removed on the first phases here. And at the end, of course, what remains will be the recommendation here. Just a very, yeah, sure, it's a very brief explanation, but you can delve into more details on this paper, and you can see, for instance, different types of requests which can be handled and which are provided in this current service here. So, like if you want a specific class, a specific model, or a class that has, or a model that has specific classes, or so on. So the way how it works, as I said, so it is a REST API which is hosted on a Linux server provided by CLMS, and sure, the results it provides are all uh, as a REST API. For instance, if you ask here, if you want to test it, for you can see that the way how it works. Let's say, give me a trip model. As I said, it gets the relevant tokens to construct and to determine the intent of the user here, and then it provide the respective entity. Yeah, let's say from directly from the server, let's say give me a trip model. If we prompt this response, it provides a lot of models as a result that match the tokens. For instance, the respective domain here is trip here. So give me a trip model that intent the user seems to be within this domain, and the matching token to determine this domain is trip here. And the classes relevant to this models, so trip model, so domain here is actually the name of the model, and the belonging or relevant classes to its model are, for instance, this one here. And of course, there should be other models that can match for this. For instance, yeah, let's say we see here, for instance, there is another model, DTO, which is called DTO, and it has also the entity, the token trip within it, and also a lot of relevant classes that belongs to the trip domain, uh, and which of course can be provided. So for in our case on the zAppDev local platform, only the first uh, only the first models, the first recommendation is taken onto account here. For instance, this one, and the classes belonging to this model will be recommended here. So as we said, for instance, here, if we said, give me a trip model here, only the classes belonging to the first, so to the top recommended model will be provided here. Even though there may be other models, but as we also explained in our paper, so they are ranked based on the matching tokens, and as many tokens matched, so the ranking will be higher to the model here. Yes, so If we select any class here, it will be, as said, directly recommended to it will be directly integrated within the modeling canvas. And of course, you can use it directly also by using other approaches, as we explained in our previous videos. Let's say, like finding no n-grams or suggestion related to it. They will be directly recommended and integrated within the modeling canvas. So this is a brief explanation, a demonstration actually about how Bora, how this approach performs, which is also, yes, built a bit on top of Bora or previous uh, model recommendation approach. And of course, for more details, you can uh, read our paper, where you can find how everything is constructed and everything uh, works here. So thanks for watching this video, and I hope you found it useful. Thanks a lot.